I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. And I'm sharing with all of you guys all my tips and tricks that I use to get an A in my classes, and hopefully these will help you as well in your own pre-med prerequisites. As a side note, since I've taken all these prereqs, I have been making videos on different classes on anatomy, on organic chemistry, on general chemistry, biology, genetics, etc. And I have them on playlists on YouTube, so go check that out. And please follow me here and on YouTube. Going back to this video, I wanted to talk about chair conformations because it's something that trips up a lot of students, especially when they see these type of diagrams for the first time. I know that when I was learning it, I was like, OMG, how am I going to do that? But I promise you it's not that bad. It's just a chair. No pun intended. Yes, intended. Okay, so let's go over it. So the first thing I want you to do is to draw a regular cyclohexane. And so that's what I did for you guys already. And I put a dash and a bold on every single carbon. So here I put bold, then a dash, then a bold, then a dash, and you get the point. So I think the easiest way is that you grab one. So for example, I'm going to grab the bold. And I'm going to put, I have my groups on there, right? So for every bold, I'm going to put in order. So first axial, then equatorial. Then axial, then equatorial. Then axial, then equatorial. Then I'm going to draw all the dashes. So here are all the dashes. So I'm going to do, since this one was axial, this one has to be equatorial. So equatorial, axial, equatorial, axial, equatorial, axial. Okay, now what are you going to do? Well, you're going to draw it. One is going to be like this. So here I put, for example, this is axial. Axial, you have to think axis, like the X and Y axis. So it's like it's on the Y. So here you go. This is a straight line. So that's axial, okay? Just for you guys that are like, what is axial? What is equatorial? And then equatorial, you have to think like it's like a kind of diagonal. You'll see right now. So again, this is my carbon 1. Again, here, if you look, this is CH3 on carbon 1, my CH3 on carbon 1 in the axial position, which is this. So then on carbon 2, what do I have? In this case, I wanted to make it really easy for you guys, so I only put a methyl group. But for example, if I had some other group, I would see where it is and then draw it accordingly, and I have other examples. So again, the same way that this could be in the axial position, it could also be in the equatorial position. But notice that I flip. So I can draw it. Oh, one thing I forgot to mention. Sorry, there's so many things in organic chemistry. So the way that I have mine set up is that if I am bold, that means I'm going up. If I'm in dash, that means I'm going down. So D for down or D for dash. So bold is up. So that's why this is bold. So it's going up and it's axial. Okay. So in this case, I'm still going to be going up. Okay. Even if I'm in equatorial position. So I know that sounds really confusing. So let me say that one more time. In the same way that I could have my methyl group in axial, I could also have it in equatorial. And so that's why I drew two different chairs. And the reason I drew it on here and not on here is because this is going down. And this is going up. So I need to be in another position going up. But instead of axial, I'm going to be doing equatorial. And so then when you compare and you're like, which group is better? The group that is better is always going to be the equatorial position. Why? because equatorial is more stable, it's less energy, and the axial position isn't favored because of steric hindrance and like diaxial interactions. So if you think about it, when I was talking about Newman projections and I was telling you guys about stability, and we talked about, for example, the anti-conformation, we talked about gauche, we talked about staggered, and I told you guys that anti-conformation was the best because if you have eclipsed, that's going to be too much energy. This is kind of like your eclipse version. If you're axial, it's like an eclipse. But if you are equatorial, then you're like in an anti-conformation, you're like in a staggered conformation, so you're less energy and you're more stable, and it's better for the big groups. So this was just like me introducing the topic. So now let's get into some examples.